Hey guys, and welcome to another week of Slice Swarm, where this week we are going to be going into assemblies. So at its most simple stage, an assembly is basically just a collection of components that are joined in certain ways, whether it be rigidly, rotationally, planarly, lots of different ways, but it's just multiple parts that are brought together. For this week's project, we'll be making a fire piston. This is a really cool survival tool where it basically has a piston and a piston body, and you slap them together, and the sudden spike in pressure also makes a spike in temperature. So if you have a little bit of flammable material in there, a little bit of tinder or cloth, you can actually cause it to ember and then make a fire. A fire that requires no matches, no sparks, nothing, just pressure. And it's a very popular and simple machining project. So if you're looking to get into metal lathing or metal milling, this is a really good project to get started with. We'll be working with some external components today, which basically means we'll be having a big folder full of all of our individual pieces that we can then click and drag into our main assembly file. So to get started off, we are going to be setting our units to be set to inches because we are going to be making this into a metal working project. So go ahead and change this to inches and then set this as your default and click OK. Now we're going to be going up to the top left corner and opening up our data panel, where we actually want to make a brand new folder called Fire Piston. And within this folder, this is where we can have our big assembly file and then also all of our smaller components. Because this project will be using external components, we can essentially either make it in this big assembly file, or if it's a little bit too chaotic, if there's too many components in the way, then we can always work on it in its own separate file. This is my personal favorite way to work with assemblies, but if you find that you prefer internal components that we'll go over next, that is completely your choice. So this screen that we have right here, this is going to be our assembly file. So go ahead and click save, and we're going to save this as 000 assembly. The reason that I put 000 at the front is just to make sure it's always at the very top of our list of components. So we'll go ahead and save this, and then we're going to be putting in our first component. We can go up to our assemble menu and click new component, and this one is going to be set to external. So just like with all components, you always want to make sure that you name it as your very first thing. It is really, really easy if you're making an assembly with hundreds of components to get lost and mixed up which one is which. So go ahead and name this first part our piston body and click OK. And what this will do is bring up a new menu called Edit in Place. This basically means we can edit or actually design our components with all of the rest of our other components taken into account. We can also save this and work on it as its own separate tab if we wanted to. But we can just click OK, and we are going to be starting off today with making a new sketch on the front plane. So to start off with our sketch, I'm going to go ahead and click L for our line tool, and the very first thing we'll put down is this little horizontal construction line. So I can make this a construction line just by clicking X on my keyboard, and then to add in our little sketch that we have just above it, this will define our piston body. The piston body is basically the hollow chamber that our piston is going to be going into. You can think of it in a very similar way to a car body, where a piston is going to be going into a piston chamber. So our sketch is going to be just a simple set of lines, nothing too intense. We are going to be adding in a little diagonal line right here, and then a little step up, over, and then a little step down. So within this entire sketch, this section right here that is slightly raised, this is going to be a grip section known as a knurling. You'll remember knurling from what we made in the geocache episode not too long ago. This little angled line, this is going to end up being 45 degrees for a O-ring to be compressed into. And then this little step right here, this is going to be a section for a thread to be fitting into. It's very small in the drawing, but don't forget to put it in. I do want to be putting in some of our constraints in here, so I'm going to go ahead and click our coincident tool. I'm going to click this left vertical line and our origin, and then I may as well click the very end of our construction line and make that coincidentally connected to our right vertical line. There we are. So now I can get rid of my constraint tool and click D for dimension. And the first thing I'm going to do is actually dimension the entire width of my piece, which is going to be 4 inches long. Very often, anytime I'm doing a sketch, it's much easier to dimension the outside, which kind of sets the scale, and then work into our smaller details. For example, I could absolutely put in all the small details here and here, but it's much easier to actually put in all the larger dimensions first and then whittle a little bit downwards. You can see in this scenario, it's actually pushed some of our sketches over, so we can just click and drag it so it's roughly in the right place. The one dimension that is really important to talk about is going to be the diameter of our hole, or this is known as our bore. Because our piston is going to be made out of a very standard bit of material that is 3/8 of an inch in diameter, and we want our hole to be just ever so slightly larger than this piston, we need to work by adding on 1 extra increment. So in drill bits, very often it'll be divisible into a 1/64 of an inch increment. So a 1/64 above 3/8 of an inch will give us 25/64 of an inch. And that's going to be the distance from here all the way to the other side when we end up revolving this part. But for now, because we're just making a single profile, we need to make it a radius. So I'm going to use our dimension tool again and click this bottom line, click our construction line, move it over, and this wants to be 25 divided by 64 divided by 2. And then following the packet, you guys can go ahead and add in all of your dimensions. So our sketch dimensions are looking good. Remember, if you ever want to check if everything is fully defined, you can always expand your sketches and look out for that red check mark. But everything's looking good in our sketch, so now we can make a very simple revolution. So let's go ahead and finish sketch, and then let's open that sketch back up. We do want to put in a very normal revolution, so anytime I'm converting from a 2D sketch to a 3D body, you always want to have this good 3-dimensional view. So our profile is going to be the one we just made, and our axis is going to be this construction line. And as soon as we do that and click OK, we have got our perfect body. That looks great. So the chamfer that we have on the very edge of this is actually a heck of a lot bigger than any other chamfers that we've made. And that's because this is basically known as a compression center. We want to have a threaded section on this wall where we can put in an end cap with an O-ring in there to give us an airtight fit. And what this chamfered section will do is basically, as we turn this end cap tighter and tighter, that O-ring is going to be compressed and give us a better and better tight fit. So let's go ahead and add in a little threaded area right there with our threaded tool. And this should automatically go to a 3/8/16 UNC. That's great. And we want to make this a modeled thread as well. And let's click OK as well. And then we can zoom out and knock down some of these sharp corners that we have over here. So let's go ahead and click our chamfer tool and click this outer edge over here, and then the other sharp edge on the other side. And let's make this a 0.02 chamfer. That's a nice light chamfer that you can do relatively easy with just a hand file. So now that we have this part that is looking a little bit closer to our final product, you can go ahead and click Finish, Edit in Sketch, and then save this. And as soon as we do this, as soon as it's all saved, we can actually open up our data panel and you can see, yes, we do have our original assembly file, but we also have our individual piston file. So if we wanted to open this up, it would just open up as a separate tab over here, just like any normal projects. If we want to go back and edit this part within our assembly file, very simply move over to the component and click this little pencil icon, and it'll give you back into the Finish Edit in Place area. One downside to this is that you will notice some of our tools are actually missing. So if you look into the Create section, it's a little bit simplified. And in some projects, you actually need those tools that were taken away. So in some scenarios, editing in place, just like you would in an internal component, is great. In some certain scenarios, maybe not so great. So for me, external components are the way to go. So our next portion is going to be adding on a knurled section to the middle. This is going to be our handle where we grab it. And unfortunately, we need to use our Coil Tool, but if we check in the Create section, there is no Coil Tool. So we're going to have to be working on this as a separate tab. So we can just say, yep, finish this in place, open up our data panel, and then we want to double click on our piston body, and this will then pop up, there we go, as its own separate tab. And then if we click down on the Create menu, yep, our Coil Tool is right there. Now the coil that we put on here is going to be starting from this face and extending all the way out to this top section. So the reason this knurled area is actually raised up above is because knurling isn't a cutting operation, it's a masticating section. You basically will have a blade cutting into the surface and then pushing the material outwards. This is why it works so great as a grip. You're actually pushing material outwards and giving it a three-dimensional feel. We are going to be kind of reverse engineering that effect by already having a raised section and then cutting out the grooves that you would see from a knurl. So we'll go into our create section, select our coil tool, and we want to start off by clicking that little shoulder. You'll see a little origin start up right there, so we can click that origin and then pull it right out to our larger circle there. And as soon as we do that, we have this little red springy section coming in. Not only is this going the wrong section, it's the wrong size, it's the wrong shape, so we're gonna have to do a lot of editing with this. So go ahead and drag one of these arrows and pull it so it's at least going in the right direction. And what you'll notice is as I'm pulling this, in our dialog box, our height is actually changing as well. This is because we've set this to a revolution and height section. But you can basically choose any of these different types of coils that you'd like, whichever works best with your project. So all of our information that we put into our coil dialog box here, you can grab from our packet, but we are basically just trying to make a very shallow, small, internal triangular cut. So our diameter is that 0.73, which we already established from the very top of our arc. Our revolutions, we're going to set this to 1.6. This kind of seems like an arbitrary number, but we want to get this kind of 45-degree angle cut that you would find on something like a diamond knurl. The height, we are going to be set this to -2.5 because that is the length of this raised section. You could have also done this parametrically by when you were starting your sketch, making something called a knurl length and then a knurl height. As far as the knurl height goes, that's going to be the raised amount of that knurled section, which would be in our section size, and that would be 0.04. There we go. So now we've got a really small shape. But as you can see, it is still a circular profile. Let's change that a little bit. So in our section, instead of circular, we want to make this an internal triangle, and that will give us, well, a triangular cut that you would find on a knurl. And then for our section position, we actually want to set this to the inside, so it will cut all the way through our material. If your part isn't red all the way through, you may want to double check that your operation isn't set to join or new body or anything like that. It has to be set to cut. Then we can just click OK. Now this spiral that we have on here does look kind of cool, but we want to have a diamond knurl in our project. So I'm going to go up here to our mirror tool over there. Instead of type, we're going to change this to features. And the feature that we would like to mirror is going to be this coil down here in our timeline. And the mirror plane really doesn't matter too much. You can either choose what would be the front plane or the top plane, really doesn't matter. We just want to see that little preview where these two lines cross over each other. Then we can click OK. And this would be a pretty gigantic knurl. Obviously we would like more of these. So we're going to go and use a pattern here. In fact, we're going to be using a circular pattern. And again, instead of clicking the faces, we would like to click the features. The objects that we would like to make a circular pattern for would be the original coil and that mirror that we just made. Our axis is going to be the red x-axis. If we can click through it, nope, we'll have to zoom out and click that little red line there. And then as far as the quantity, if we have too many of the knurls, it may look more accurate, but it is so much data, it's actually very likely to slow down your computer. And we're just looking for what looks like a knurl. So if you're going to manufacture this, you go, okay, that's a diamond knurl on top. I know exactly what to do. So we're just going to make this quantity 10. That way it still looks good, but it's not so much data that's actually throttling your computer. So let's click OK, and that's going to process right there. And there we go. We have a very, very coarse diamond knurl. That's going to be great for a survival scenario. If you're wearing gloves or anything, you've got to have a pretty coarse grip on there. That looks fantastic. Now the last thing that we're going to be doing to this component is adding on an appearance. Now the appearance that we're going to do by clicking A is going to be adding what's called an anodization to the surface. So this is going to be an aluminum part, but very often aluminum gets scratched, it gets damaged really easily, and so you'll find a lot of aluminum parts will have an anodization put onto it. That's why some parts that you may buy or see in the store are actually colored like a crazy blue or a shiny red or something like that. It is an anodization. This is a chemical process where we can actually increase the oxide layer of aluminum, and it opens up lots of different pores that will allow it to take a paint much more easily, and it also protects your part a heck of a lot more. So you'll find anodization in things like soda cans, metal carabiners, basically any aluminum part that actually has to have that little bit extra strength with it. So we can just go into our appearance and look up any of our different anodizations. You can see it has lots and lots of different colors, rough, shiny. I think the shiny blue looks best. So let's go ahead and click and drag that onto our parts. There we go. So now this component is essentially done. All of the features on there, they all look great. So I'm going to go ahead and save this part. But then if I go back into my assembly, you'll see I've got this really big warning sign. It's basically saying, hey, this component is out of date. It needs to be resynced. You'll see this warning pops up. Don't worry about that. You can just click this little icon up at the top. It's now going to be taking information from that individual file and updating it into this assembly, and then all is well in the world. And this component is now perfect. So now we can add on another new component just by going up to our new component section over here. So just like normal, we are going to be starting off with an external component. This one is going to be called the body end cap. And this is going to be screwed into that little section on the back. And in between these two components is going to be a really chunky O-ring that as we tighten on this end cap, that's going to be compressed and then give us a really good end seal. So we can go ahead and click OK, and then you'll see this body pop up. One thing that I will note that's very, very important, I'm going to go ahead and finish this sketch, is that when I added the new component, my top file was activated. This little white dot was actually pressed right there. You'll notice that if I cycle over any of my other ones, I can also enable those as well. If you already have this component activated and then you say add a new component, you're essentially making a sub-assembly folder, which in this scenario we really don't need. We don't have that many components. So always go up here and activate the top component and then add a new component. Very important. The other thing we want to do is also ground this component. Right now, it's kind of currently floating throughout the universe, and we want this to be locked down. So we can go ahead and right-click where it says Piston Body, and then click Ground. And then you'll see a little thumbtack icon right there that's saying, hey, this is fully cemented down. Now we're going to go back to our end cap right here and click that little pencil icon, and now we're back into the Edit in Place mode. This is a place where you can work, but things tend to get a little bit messy. So we're just going to make a little sketch right over here. So when we do the rest of our work on our component as a separate tab, our component isn't interfering with anything else. It's already kind of in the right location. So I'm just going to make a brand new sketch. We're going to be making it on the front plane. And I know it's going to be screwing into this thread portion right there. So I'm going to make it just right next to it. With our line tool, we are going to be making a little central axis. All this portion that I'm working on right now, this is going to end up being the head of our screw. I'll go back to our line tool again. I'm going to be making a little angled section. This little line here, this will end up being our threaded portion. But because we want our O-ring to be kind of comfortably seated, instead of joining these two sections, I'm actually going to have a little arc that goes in between it. Nothing too difficult, just click these 2 points, pull your cursor kind of away, and then click Escape. You'll notice that I do have a tangent constraint on one part of my arc, but not on the other. There's this kind of funky little corner right there. So let's add a tangent constraint to that end as well. We also want to make sure that this bottom section doesn't go up or above or below our origin. So we can just have a coincident relationship between that bottom horizontal line and our origin. There we go. Now we can put in the rest of our sketch dimensions. And great, all of our dimensions are put in place. You will still notice that there are some lines that are still blue, meaning it's undefined, and that's just because I can move it left and right. We can fix this very easily just by using our fix constraint right here and clicking any point on this piece. And if the rest of the lines turn black, that means everything is fully defined. So let's go ahead and hit Finish Sketch. And then just like before, we are going to be revolving this profile about that bottom horizontal line, and then clicking OK. And then we have a good little end cap right there. Now we want a little bit of contrast with our material, so I'm going to be making this into a brass piece. In fact, we're going to be making this into a polished brass. Brass is a really easy material to work with on a metal lathe. It does get rather hot because it holds onto its heat really efficiently. But these sharp corners, again, we do want to knock those down a little bit. So just like with the piston body, we're going to select these outer two edges and give it a 0.02 inch chamfer. Now I do want to have some kind of grippy surface on this outer face and this front edge, because this is going to be the section of our piece where we have to kind of screw it in really hard and then potentially have this be pressed down on a surface that we can then smack into. And we may as well make this look kind of nice, so we'll put in kind of a decorative feature into this. But we're going to be using a lathe tool that actually has a certain amount of radius to the nose of it to make a series of cuts on these faces. And this can just be a very simple revolution cut, but we need to make all of these circles on here. So I'm going to be making a brand new sketch. We can be making this on the front plane and zooming in on there. I don't need to see my body. I can actually turn that off in my browser, but I do want to see that original sketch that we made. And we're going to be making a series of circles on this top edge and on this far right edge. So we can project those so we can actually work with them. So click P, select these two lines, and then click OK. And then I want to put in a series of circles all the way along each edge. So using my circle tool, by clicking C, I'm just going to make 6 circles all the way along here. They do not have to be in the right size or the right direction. It doesn't matter one bit. I do want to hold down Control and click these top circles and then add a horizontal constraint and do the same thing with these vertical lines. Hold down Control, click the origins, and then select horizontal vertical tool. I also want to do the same thing by holding down Control and selecting all of my circles and then adding an equal constraint to all of them. So if I change the size of one, the others will change as well. So the last bit of geometry that I want to use is by adding a point to the midline or the midpoint of both of our lines. So you can see when I move my mouse closer, that little triangular icon will pop up. Same thing for both ends, and this will allow us to make sure our middle circle lines up perfectly with that point as well. So we can also add another horizontal constraint and then a vertical constraint to that line. There we go. So now I can add in all of my constraints, or all of my dimensions, excuse me. So I can click D, select any of the circles I'd like, and this wants to be 1 divided by 16. This is a pretty common nose radius you'll find on the very end of a lathe tool. The distance between these top circles wants to be 0.14 inches. So the same thing on both sides. And then for these bottom sections, because we have a slightly smaller area, this wants to be 0.1. Oh, it's already put in place. Ain't that handy? 0.1. There we go, perfect. And then now we can move all of our circles to the same depth, but now we have to be concerned with what is our depth of cut, or DOC. For us, we want it to be pretty small, about 2/100th of an inch. And unfortunately, I can't click the very bottom point to our circles. It's just not a feature that's kind of enabled. So we're going to be having to add a point somewhere that's kind of on the lower section of our circles. And then using our horizontal and vertical constraint, making sure that point lines up with our circles as best as we can. There we go. And then we can just click D and then select our projected line and that bottom point. Like I said, 0.02 inches is going to be a pretty normal depth of cut. And same thing for the other side. Whoops, 0.02. There we go. And as soon as we do this, everything should be fully defined, fully constrained. That's great. And now we can make a revolution for this. So let's go ahead and finish this sketch and then get a 3-dimensional view. And then we want to make a revolution of this. So we can just click not the entire plane, that may be a little tricky, but we want to click just the bottom halves of all of these circles. don't want to click the entire face, just the little moon. Ooh, gosh, is that tricky. Well, anyways, go ahead and click all of those, and then our axis wants to be this little bottom bar right there. So after we do this, we will have all of these series of cutouts, and if we turn on our body again, you can see exactly how it's going to be cut. And click OK, and then turning off that original sketch. That looks great. This is a threaded section, so we do want to add a little thread to this end, and we want to model it. And because we modeled this to be a 3/8 inch diameter, it's going to be automatically set to a 3/8 1/16. This is a really chunky, heavy-duty thread, and because it's going to be holding onto a lot of pressure and a pretty high amount of heat, it needs to be pretty substantial. So we can just click OK. So this component is pretty well done and dusted, so we're going to go ahead and hit Finish Edit in Place, and now we have one component that is fully locked down and another component that is free floating. Now before I join this part into the other piece, I do want to have an O-ring in the middle. This is a part that we could make if we wanted to, but we can also import this from a different server. So if we go into Insert, we can actually open up our McMaster car component. And this is where we have our new menu, where you can type in our little code for our O-ring that you can get right from our packets. And when we do this, this will open up all of the O-rings that they have. It's a lot. And then it will find our O-ring that we need. Now, when we have this, we want to download not the 3D SolidWorks file, which is for a different CAD program, but we want to download the 3D step file. And then as soon as we click download, it will then import this. And it's always going to put it at the origin, but as you can see, that's kind of interfering. So you can just drag this over and then flip it over so it's about in the right orientation, and then click OK. Now this is our rubber O-ring, and it wants to be fitting in place. But as you can see, we can still move everything about, so that means we have to be putting in a joint. So we'll be going into joints much more in depth next week, but for right now, we are just going to be adding in some rigid joints. So if you go into your Assemble menu, you can click J for joint, and we can basically rigidly attach multiple components together. So I'm just going to be clicking the O-ring, and then I'm going to be clicking this little curved surface that we made on there, and that'll bring it and join it up perfectly together. Now these are fully connected, so I can click OK. Now if I move one, the other will move with it as well. So now I want to join this, technically a sub-assembly, onto our final piece. So again, we can just use a joint, and then I want to click not on this flat shoulder, but on the ring just above it. So you can see the origin pops in right in the middle of that circle. Then we can zoom out, go to our other piece, and similarly, we want to grab this outer ring, and there we go. Then our pieces are totally joined in place. And by clicking OK and then doing a little section analysis of this, we can actually peer into the model itself, and you can see, yep, we have this little pink, which is our piston body. We have our end cap, and this little O-ring is right here. What you'll notice pretty immediately is that this O-ring is actually not in the right location, and that's why we have this little angled chamfer right here and this little curved section on our bolt. And that's because our O-ring is made of a really rubbery material, and so it can actually be stretched and pushed. So we don't care that it's interfering with our project, because we know in the real world, as we tighten down this screw, it's going to get pushed in and expanded in this joint. That looks great. So let's go ahead and click cancel. And then with our top component totally activated, we are going to be making a brand new component. Now this component is going to be called Piston End. It's going to be the end screw cap of our entire piston mechanism. This is the area that you would actually hit into our chamber. So let's go ahead and hit OK. Again, as soon as we do this, we are being placed into the Edit in Place menu. We really don't need that because, again, all of our components are going to be kind of overlapping each other. We want to work with it as its own separate file. So I can just hit Finish in Place, save this file, and I'm really just saving the piston end. Technically a file that contains nothing. It's just a blank canvas. But when we go into our data panel, we've got our piston end right there. So let's double click this and it will open it up as a new blank tab. So anything that we make in here, it will automatically get pulled into our main assembly file when we update it. So we are going to be making a new sketch on the front plane, and we're going to be making essentially another bolt. This is a very special bolt though. This is going to be having the exact same rotational ring pattern that we had on the other bolt, but this is going to be a little bit more of an aggressively sized bolt because it needs to be very well secured to our entire piston. So using our line tool, we're going to be starting from the origin, making the bolt head now on the other side. We're going to be making this little gouge in the middle. This is called a gutter in metalworking. That horizontal line, that was going to be our threaded section, then a little angle for a chamfer, and then down to complete our piece. And then we can just hit escape. So with our dimension tool, again, we are going to be designing this very similarly to our other piece. So this wants to be 0.5 inches, and again, 1 inch total, so 0.5 and 0.5. And we can always drag around any of our sketches to put them about in the right location. This little gouge right here, this is called a gutter because this is where, as you start to thread, you want to make sure that your thread is actually extended all the way to the end. That you don't have some fully formed threads at the beginning of the bolt and some kind of not all the way made at the very end. So by cutting in this little section, we can guarantee that our threads that are along this entire flap section are fully formed. The tool that you would make to cut this is called a parting off tool, and those are usually a pretty standard 1/8 inch. So again, I'm just going to dimension this as 0.125, and then we want to have our entire diameter be 1/4 of an inch, which means our radius is again going to be 0.125. There we are. Our angled line, just like always, going to be 45 degrees, and this angled line doesn't need to be very large, so we can just make this 0.05 inches. That's perfect. And then our last two dimensions that we are going to be putting is the diameter of our head. This is going to be 0.345. This will line up very neatly with our entire piston body. And then our threading diameter, this is going to be 5/16 of an inch divided by 2 to give us our radius. 5/16 is a pretty standard thread as well. So we can just click Finish Sketch. Just like always, we're going to be revolving this profile about its bottom edge. That's great, clicking OK. We do want to give this a polished brass appearance. So we can just type in brass, bring on that polished. Oh, that always looks good. And then we can add in our threading section right there. So using our threading tool, we can select this. It should automatically go to a 5/16 with an 18 TPI. I would like to make this a modeled thread and click OK. And then just like on the back section and the back face, we're going to be putting in the same sketch and the same revolution cuts that we did on our other piece. So go ahead and grab all of the dimensions from that other section, and I'll meet you guys at the end of this component. That looks fantastic. And then to finish off this component, we are just going to be cutting off those really sharp corners by giving it a 0.02 chamfer. Fantastic. So now we can save this part and then go into our assembly, re-update this. And then this is going to be placing a new component over the origin. So we can just pull this over because we are going to be making our piston as our next stage. So our last component that we'll be making will be our piston. Again, we want to make sure that we have an external component and we're naming it right away. Clicking OK, and right now we can say, hey, do you want to revert to the most previous position or capture the position? For us, it really doesn't matter all that much. Pick either one you want. Again, we do want to make this as its own separate tab, so we can just say, yeah, but let's finish this, save that individual file, go back into our data panel where our piston will be awaiting us, double click it, and then this will pop up as its own separate tab. We do also have our piston end right here. We're not going to be working with it anymore, so you can just go ahead and close that. This is going to be made up of a sketch on the front plane, where it is essentially just a rectangle that that will start at the origin, go to the upright section, and then make a circle that is coincident with the horizontal top line, and then pull it out. Very, very simple sketch for today. So to dimension this piece, we want it to be a total length of 3.5 inches. This is so long that it means that it won't bottom out when we fully compress the piston inside the piston body. We want to make the circle that we have here, which will have our O-ring seating over it. This wants to be the same diameter as the nose of our lathe cutting tool, just like we made on the 2 bolts. This is going to be a 1/16 of an inch, and is going to be living 0.2 inches from the very end of our rectangle. And the total radius, or the diameter of the piston, like we said when we were constructing the piston body, is going to be 3/8 of an inch, perfectly standard dimension when you're buying metal. So for the radius, we can just type 3 divided by 8, and then divided by 2 to give us our radius. Great, and then we can just finish this sketch and then make a revolution of this profile about that bottom line. There we go. Make sure when you do that it's only selecting that one profile, and that'll give us this circular groove over here for our O-ring to go over. So this part is also going to be a brass piece, so we can go ahead and add that as our appearance. And then this end, which is actually going to be inserted into the piston body, we want to have a little bit of features where our little bit of tinder can actually be held inside. So we can do this with multiple features if we wanted to, or we can add essentially a countersunk hole that'll act as a really good holding mechanism. So I'm going to type H for hole, and I'm going to select this face. And then I can drag this little blue dot, and it should snap, there we go, to the very center of our circle. Now this isn't just a normal drilled out hole, this is also going to be having a countersink in there as well. So we're really only worried about what is that diameter of that top countersink, what is the depth of our hole, and then what is the diameter of that smaller drilled hole as well. So this top line, which will be our depth, this is going to be a 3/16 inch of depth. Our countersink is going to be 1/4 of an inch, and then the diameter of our hole is going to be 1/8 of an inch. And what that will do is give us, well, if we do a little bit of a section analysis to kind of see the whole product, is that this will give us a lot of holding geometry to kind of grab onto that bit of paper or that bit of tinder, or whatever you'd like. So we're going to be doing a very similar operation to this back end, where we can add a threaded hole that'll screw into our end cap. So again, click H for hole, select this back face, and then we can move this little blue dot so it snaps to that center of the circle. Now this hole doesn't need to be countersunk, so we can just make this into a simple hole type, but it does need to be tapped. And this is where we can add in our 5/16 of an inch, which will interface really nicely with our bolt. So the designation, or the size, excuse me, this is going to be set to 0.3125, and then the depth of my cut wants to be a 1/2 inch, so it doesn't bottom out. And again, we also want this to be a modeled hole. And then we can just click OK. And just like with any metal parts that we have, we always want to add a chamfer to any sharp external corners, and this one again is going to be 0.02 inches. So you can just click that, and then this piece is basically finished. It's a very, very simple part. So now we can save this, and then go back into our assembly file. It's saying, hey, you've got some update or some parts that aren't up to date. So we can just go ahead and update that, which will bring in our component, but it's kind of hidden inside. So we'll click and drag that out. And this piston and this piston end cap do need to be joined together. So we can just type J for joint. On any of these pieces, we can select the most furthest out ring, which will put a little joint icon at the center of that circle. Zoom out, similar piece, we want that to be screwed all the way up to this back face, so we can click that outer circle. That'll bring them both together, fantastic, and now these two pieces are joined. Now the last component that we are going to be putting into place is another O-ring that lives right on this grooved joint, so we can just add in another McMaster car component. Again, this code can be found from your packet. So we want to download this 3D step file, bring it over so it's about in the right orientation and location. We need to flip this up 90 degrees. And then we can just add a very simple joint. So again, our joint tool, we're going to be selecting this groove, selecting our O-ring, and then put it in place. Annoyingly, because, well, it doesn't know that it's made of rubber, it's just barely poking through on our piece. Not an issue in real life. This O-ring would just be stretched over this piece. But now we have our two completed sub-assemblies. So as the final joint to bring these two components together, we can actually add in a special joint called a slider, where you have two components that can only slide linearly in one direction. So I can select joint, and then there's a little pop-up right here. Currently it's at rigid, which means everything is fully locked together. We are going to be changing this over to slider. So again, our first components that we would like to snap to, that's going to be the outer ring at the furthest section. You'll notice that the little origin is set in the middle, so I can select this outer surface or this inner surface. Either one works. And then I can flip around over, and again, similar thing, I can grab this outer ring, or this inner ring, excuse me, or this outer ring. It doesn't make a difference. And now this can move in and out perfectly, just like in real life. When I click this though, I can grab one end, but it actually clips all the way through my part. Not fantastically realistic. So what I want to do is put in something called a contact set. This adds a little bit of realism to our parts, where basically if two components bump into each other, it'll say, hey, there's an interference, I can't allow that. There's some certain contact where they can't pass through each other. So this can be found in the Assemble menu, where I can say, yep, I want to enable all of the contact sets. In this browser over here, I can say, yep, I want to have all bodies be contacted. So I can pull this out all the way, but as soon as I try and push this in and it meets that end stop, it's totally stopped. That looks fantastic. And that is going to be it for this project. I hope you guys have fun. Now go ahead and make a fire piston and go camping.